the receiver has dumped the memory location data for its 1000 locations into the software, and the corresponding counter on the software has indicated 100%. That means all the data for the locations has been dumped. Now the software is asking for whether we want to save the previous data. Since we never experimented for the previous data, we can say no. On saying no, the software is displaying this plot for the phased array. You can see it is a reasonably beautiful plot, and it is right now in the absolute condition. When we press the relative mode, then we can see that the phased array plot is being displayed. The back lobes are, we can switch on the cursor movement in the system, and we can analyze the front and back lobes of the system. The side lobes are rather high, and that may be attributable to the reflections in the room. We see a very good null on one side of the room. We can see that we have a big reflection. It is a concrete structure. We think that it could be one of the reasons for these reflections, which show that the pattern is disturbed on one side. And what we told you about the stitching is the error of 2 to 3 dBs here. We can try to overlap that. But it is better we can remove this totally by starting, as we told you, about the antenna initial position as 90 degrees. Now we need to, this is the normalized pattern for the phase system. We can observe the beam width and the front to back ratios. The front to back ratio can be found as by clicking the cursors, and the front to back ratio right now is about 15 dBs is the level difference between the front and back lobes. The 3 dB beam width for this particular antenna can be found out as 11 degrees. Since it is a narrow beam antenna with a 11 degree beam width, we advise to remove the stitching error by rotating the antenna in the 90 degree as the initial plot. Now after we have done the initial plot, then we will start the experiment of phase shifting the beam by giving incremental phase shifts of 30 degrees. Now we can see that 30 degree correspond to a phase to a voltage of roughly 3 volts is corresponding to 20 degrees, and 5 volt is corresponding to 55 degrees, and for 90 degree you have got about 6 volts. It same can be interpolated from the graph as well. We'll try to keep that voltages from the, we'll try to read that out from the display here. As you can see, number 1 is showing 0 degree. That means this is the 0 degree phase shift for 1 and 5 patch antennas. For patch antennas corresponding to 2 and 6, we will keep 30 degree phase shifts. For 30 degree, we will have to introduce a voltage of roughly 3.5 volts. We can increase that voltage and read the voltage from the display here. So this is roughly, say, 3.5 volts. Now we keep the same thing for the 6. We'll select 6 number control and introduce the same phase shift here as well of 3.5 volts. Now we keep the system to number 3 patch antenna and we introduce 60-degree phase shift. For 60-degree phase shift, the voltage is roughly 5.5 volts. So we keep number 3 as 5.5 volts. We keep the same voltage or the same phase difference for patch number 7 as well. So we go to number 7 and keep that as 5.5 volts. Now we give patch number 4 90-degree phase shift. 90-degree phase shift will correspond to a voltage of 5, 6. So a 90-degree phase shift will come with a voltage of about 6.5 volts. We'll try to keep that as 6.5 volts. Number 4 as 6.5 volts. And number 8 also as 6.5 volts. Once the phase shift has been introduced, we will rotate the system back to its initial location by unscrewing the cables at the back and rotating the antenna. Now we have again connected the cable. The required phase shift has been given to the system. This is our initial location for the phase shift. 73 is our starting location right now, and we can initialize the stepper controller and start off the rotations. Once again, we need to disconnect the RS-232. We need to put the system in auto mode. System has been put in auto mode. The starting location is 73 degrees. The required step size is 5 degrees. We put the system in auto mode and it starts rotating once again. And we need to back out. Now we already started from the side lobes, so we are not really bothered about the speed we came out. Just wait while the phase shifted antenna is being plotted. The starting location has been 73. We need to take note of that because we need to plot the pattern, and we can see the change in the antenna patterns once the antenna has rotated.